Okay, welcome. We're going to do a short tutorial here about arithmetic sequences and series. And first question, introduction, what are they? Not too bad, that one. We'll sort that out very quickly, but then we want to leap into these sequences. We want to say what the 10th or the 20th or the 50th term is. And finally, what we want to do is add these things up. So an arithmetic sequence or series, if we just have the numbers, it's a sequence. If we try and add it up, it's a series, nothing more than that. But let's get started. I will ask you, have a look at this particular sequence of numbers. 2, 5, 8, 11, and what do you first notice? Most people, a bit of mind reading here, most people, and I think maybe you did as well, most people spot that it goes up in 3 each time. As soon as you've done that, you've spotted what makes it arithmetic. An arithmetic sequence simply goes up with a common difference. If we add 3 each time, it's arithmetic. If we add 2 each time, it's arithmetic. If we add the same number each time, it's arithmetic. We can subtract. As long as we subtract the same number each time, it's arithmetic. And so we have got ourselves an arithmetic sequence, and maybe, maybe not, you said it started at 2 as well. As soon as you said those things, we've pretty much said it all about this sequence. What about that as a question? What's the 10th in line? Well, what I'd like you to think about is that you begin at 2, you add 3 on, but how many times, how many 3's get added on to get you to the 10th term? It's tempting to say 10, but not true. Notice to get to the 4th, you add 1, 2, 3 of them. So to get to the 10th, somewhere down here, you add, and you keep adding, you add 9 of them because you don't add the 10 to the first one. So to get to the 10th, 2 plus 3 9's. There we are. What about to get to the 30th term? Could you do that? 2, start at the beginning, keep adding 3's. How many of them do you add? Well, to get to the 30th, you would add 29 of them. At this point, I wish I'd picked a different number. 2 plus 3 times 29, we got 87. And that would give us 89. So 89 comes at the 30th point. And finally, can we give a general formula? Any term is the question. Start at 2. How many 3's? n minus 1. Tidy that up. 3n. And finally we have, there we go, any term, simple. So we can dive in, leap into a sequence in that way. Let me give you another one. What about this? Start at 20. Now straight away you're saying, well, this thing goes down in 4 each time, so it's arithmetic. The question is, what's the 10th? Somewhere down here. Start at 20, subtract 4. How many 4's do you subtract to get to the 10th? Well, 9, you say, and you get it right. There we go, minus 16 at the 10th. What about the 30th? Start at 20, subtract 4. Well, every time, it's not 30 times, but we subtract 4 29 times because we don't take it off the first. And I should have learned, but I've put in a horrible number again. Let's see if we can sort this one out. 4 times, what's that, 116, I believe. And so, there we go. Minus 96 is the 30th term, somewhere down here. Great. finally, nth term. Well, start at 20, subtract 4. How many times do you subtract it? Tidy this up. Minus minus gives a plus. 24 minus 4n for any term we want. Bingo, we've got it. Moving swiftly on, we can jump straight into these things. Can we add them up? Well, quick story. A few hundred years ago, this question was asked of a small boy called Carl Friedrich Gauss. He was German, as I'm sure you'll see from my quick picture here. There we go. There's Carl Friedrich Gauss in his short trousers. Small boy, enjoying himself. Very famous mathematician he became on to be, and apparently when he thought about this question, he answered it very quickly indeed. So there he was, small chap as he was, and what we believe he did was we believe he had a quick look at those two numbers. He had a quick look at these two numbers, and then he came up with the very fast answer, and he said 5050. I'm sure you did as well. But what did he do? Well, he looked at those two and he saw 101. In fact, we don't really know he did this, but we think, we're guessing, and it's a nice tale. He looked at those two and he saw 101, and then he looked at those two, and what did he see? He saw 101, and he saw he could make a lot of pairs. 100 numbers, 50 pairs, and each pair seems to come to a total of 101. So 50 pairs, 101 is a total, 5050. Good old Gauss came up with an answer, 5050, but he did give us a very nice method for dealing with any arithmetic series. So let's have a quick think. Let's have a quick think about the one that we started off with. 2 plus 5 plus 8, and it got all the way to, I think it was 89, wasn't it? And that was the 30th term. So 2 to 89, 30 terms. 30 terms, 15 pairs. First one, last one. And what have we got? 15 multiplied by 91. Oh dear, 15 times 91. Let me do some quick arithmetic. 10 91s, 5 91s. I think that what we've got there is 1, 3, 6, 5. There we go. So that adds up to 1365. Let's try adding another one up. Oh, I seem to have got a white screen, but we'll press on. We'll add another one up. What about 3 plus 7 plus, and on you go all the way up to 407. What is the sum of that one? First question, how many numbers have you got in this sequence? Well, we start at 3. We add, it would seem to be 4, and to get to any number we do it n minus 1 times. If we get to 407, I appear to have 102 numbers. So 102 numbers, 51 pairs, and the grand total of all those pairs is 407 plus 3, first and the last, 51, 410, and 410 times 51, which I'm sure you can work out very quickly, will give you a grand total. So 410 multiplied by 51, what have we got? 0, 1, 4, 0, 5, 20, not 1, 9, 0, 2, 20910. Bingo. There we go. 20910. We've got ourselves a grand total. Good. So finally, what can we do? We have got a sequences or series, and we can add them up and we can jump in. So if we have any old sequences or series, let's 10, 12, 14. I'm going to give some letters here just to summarise. We're going to say the first one is U, the second one is U, the third one is U. You'll start to see a problem here, so I will put a little number there. So if I get to the 10th, I will have U10, and when I get to the general any term, I'll have UN. So what I will say is the nth, UN. I start at the beginning, U1, and I add differences, in this case 2. I always add n minus 1 differences, and this tells me how to jump into a sequence or series. If I want to add it up, if I want to do a sum to any number of numbers, what I do is I see how many pairs I've got. Number of numbers divided by 2, number of pairs, and I add the very first one to the very last one, and I've got myself a grand total. And these two things, nth term and the sum, are two important formulas, two important techniques to deal with arithmetic sequences. I can have an alternative version for this. You'll notice that you have a UN and a formula for it, and there's a UN here. And what I can do is I can replace in this formula the UN. So if I want an alternative, I can take the formula here, U1 plus n minus 1 differences, and I can get a formula without UN in. So what have I got? UN, U1, U1, two lots of U1 plus n minus 1 differences, and there we go. I have myself a set of formulas to work with. I've got any term, the sum, and I've got an alternative formula here if I wish to use it. And so there we go. That's our sequences and series, and this deals with arithmetic.